right, guys, I'm going to get started. So your camera should be on. Can I get a thumbs up that you hear me and see the presentation okay? All right, here we go. Again, camera should be on. We are going to continue solving these quadratic equations. Guys, now we know that when you solve a quadratic equation, you can get imaginary numbers to it. So we now live in a world that has real number answers and imaginary number answers, okay? So just remember, when you solve a quadratic equation and you get those two answers, the two solutions, the two answers to a quadratic, guys, they can be two different real numbers, meaning that's a parabola that crosses the x-axis in two different spots. You can get the same real number twice, which means that's one of those parabolas whose vertex is the x-intercept, so it really only has one x-intercept. But now you can also get two different imaginary numbers as the solutions to that quadratic equation. And that just means that's one of those parabolas that doesn't cross the x-axis. It doesn't have any real number solutions, so it doesn't have any real numbers that it can cross the x-axis at, okay? All right, so imaginary numbers. An imaginary number happens when you take the square root of a negative number. The answer to that is going to be an imaginary number because we know there is no real number that we could square that would end up being negative. So when you take the square root of a negative number, you're going to get an imaginary answer, all right? So the imaginary number I, we know two things about it. When they created I, this imaginary number, they said let I be the number that when you square it, it equals -1. And then if that's true, if I is the number whose square is -1, then if I was to square root both of those, just I himself is the square root of -1, okay? So as long as we're working with imaginary numbers, these are the two pieces of information that you have to know about I. I squared is -1. I himself is the square root of -1. And then there's nothing you can't do with imaginary numbers as long as you know these two pieces of information. All right, so today I want to practice solving these quadratic equations when you get imaginary solutions. So I picked the first example. I want to go over that one. And then the last few examples, I'm just going to grab them off Delta Math so you guys can see what your homework for the next few days is going to look like and how you're going to be typing those answers in. All right, so everybody look at the first example. And let's solve this degree 2 quadratic equation. Now, guys, remember, you know how to solve a quadratic equation by factoring, by square roots, and by the quadratic formula. Square roots and factoring don't always work. Not every quadratic can be factored, and not every quadratic can be solved using square roots. But the quadratic formula will work every time. So if I look here, this is a problem that can be solved all three ways. Factoring would work, square roots would work, and so does the quadratic formula. However, the majority of your problems that you get assigned over the next 3 days, they all are quadratic formula problems. Usually when you get these imaginary answers, a lot of the time, you have to use the quadratic formula. All right, so I'm going to use the quadratic formula even though I could use any method. All right, so if I'm going to use the quadratic formula, I need everything on one side set equal to 0 so that I have one square term, one number, so I can identify my A, B, and C. So in this problem, A, the number in front of x squared is -2. B, the number that's supposed to be in front of x is 0 because they don't have any x's. So B is 0. And then C, the number at the end by itself, is -18. All right, so the quadratic formula says the answers to this equation, x, will be equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of it is divided by 2 times a. So let's use these values to plug into this formula and solve that quadratic equation. So x will equal, I need the opposite of b. Well, guys, b is 0, so there's no such thing as positive or negative 0. So that's just 0. Plus or minus the square root of, plug in 0 and square it for b, subtract 4 times a, which is -2, times c, which is -18. All right, and then it's all going to get divided by 2 times a, which is 2 times -2. So again, when we're working with this quadratic formula, the majority of our work is underneath this square root. We got to figure out what number are we going to be taking the square root of? Who does that b squared minus 4ac become? Now, guys, I'm just going to warn you, every single number today underneath this square root is going to be a negative number. That's how we're going to get our imaginary answers. Every single number under this square root will end up negative. All right, so we're going to get x equals 0 plus or minus the square root. Type this into your calculator, but don't put it under a square root. Hit enter and see what you get. You should get negative 144. All right, then we're going to divide that by negative 4. So guys, go back to that square root. We have to clean this up. We have to fix that. So take it off to the side, the square root of negative 144, and let's fix that. We know that the answer to the square root of negative 144, it's not a real number, guys. There's no real number that could make this true. So we know this is an imaginary number. So we got to clean it up. First, we're going to break it up into the square root of negative 1 times the square root of positive 144. Now we're going to replace the square root of negative 1 with I, because that's our imaginary unit I. He is the square root of negative 1. And that's how we get the square root of a negative number out of our answer. Now we're showing it as an imaginary solution. And then, guys, the square root of 144 is 12. He's a perfect square. So I times 12 is 12I. So you want to take the square root of negative 144 out and put 12I in its place. So now we have this. X equals 0 plus or minus 12I, all divided by negative 4. Now, guys, if you notice, they asked you to write your answer in simplest. We're always simplified. Fractions are simplified, square roots are simplified, but they asked you to write your answer in A plus BI form. That's how we write, hey, Flor, that's how we write imaginary numbers. A is going to be the real number part, completely separate, and BI is going to be the imaginary part. So you'll see that as we start getting our answers. I'll explain that more, all right? But when you get here, just me 1 second, guys. I got to give Flor a worksheet. Here you go. All right. All right. So there's 2 answers to a quadratic. One of those answers is going to be when we take 0, we add 12I and divide it by negative 4. The next answer will be when I take 0 and subtract 12I and divide it by negative 4. So now, guys, watch this. I'm not really allowed to take a real number 0 and add it with 12I. You don't really add a real number with an imaginary number, but it's 0. So really, nothing's there. It's just 12I divided by negative 4. And 12I divided by negative 4, I am allowed to divide the numbers. I get negative 3I as one of my answers. That's one of my 2 answers to this quadratic degree 2 equation. Now I come down here. I can't really take 0 and subtract 12I, a real number minus an imaginary, but it's 0, guys, so there's nothing there. This is just negative 12I divided by negative 4. And now I am allowed to divide the numbers in front. Negative 12 divided by negative 4 is positive 3 times I. And then that's your second answer. So in this problem, your answers are pure imaginary. They don't have a real part. They're just BI answers, and that's fine. So you could write your answer separate like this, or you could say my answers are plus or minus 3I, and you can write them as a combined solution. But those are the 2 numbers that will make this equation true. So guys, what does it mean? It means that the only numbers you could ever plug in for x to make this equation equal 0 are not real numbers. Only imaginary numbers are going to make this equation equal 0. It means that he does not have any real x-intercepts. This is definitely going to be the graph of a parabola that doesn't cross the x-axis, because the x values that make it equal 0 aren't real. All right? Okay, now for the next example, I'm going to pick one off of Delta Math. Is everybody okay so far? Is everybody good with these imaginary answers? Okay. All right, guys, just give me a second, because there's like certain problems that I want to make sure that I go over. So let me just go on Delta Math and grab one that I like. Perfect. Let's do this one. All right, guys, let's solve this one. This will be our example 2. So this is what your homework tonight is going to look like. Okay, they want to know what are the roots. Guys, remember roots, just a fancy word for solutions or x-intercepts, all right? What are the x-intercepts? What are the roots? What are the zeros? What are the solutions to this equation? They want your answer in simplest a plus bi form. All right, let me write this down and we'll solve it. X squared plus 16x plus 73 equals 0. All right, let me go back to okay. All right, here we go. If we're going to solve this quadratic equation, right, you could try to factor it. You would not use square roots because it has a just x, and those are definitely not solvable by square roots. It doesn't factor those, so you have to solve this with the quadratic formula. All of the problems are going to need the quadratic formula today. All right, so here we go. If everything's on one side set equal to 0, I can get a, b, and c. A is 1, b is 16, and c is 73. Let's plug them in. Let's see what we got. The solutions to this equation x will be equal to, the opposite of b is negative 16, plus or minus the square root of, I need 16 squared, minus 4 times a, which is 1, times c, which is 73, and then all of it's going to be divided by 2 times a, which is 2 times 1. So x will equal negative 16 plus or minus the square root of. We got to figure out what number this is going to become. Guys, I gave you a hint. They're all going to be negative numbers. You should get negative 36. All divided by positive 2. Okay, so let's go back to the square root. We got to fix that. Take it off to the side. The square root of negative 36. We know the answer to that is not real. It's an imaginary number. So let's break it up into the square root of negative 1 times the square root of 36. The square root of negative 1, that's I. So replace that with I, the imaginary unit. Who is the square root of 36, guys? That's 6. So this is I times 6, which is 6I. So take the square root of negative 36 out, put 6 i's in its place. So x equals negative 16 plus or minus 6i, all divided by 2. Okay, so now when you get here, guys, I'm not really allowed to take negative 16 and add or subtract an imaginary number to it. But I do have to simplify my answer and get it in that a plus bi form that they want. So what I want you guys to do now, just like we were doing before, now you got to split them. You got to split them into 2 separate fractions. Give everything on top its own denominator of 2. So we're going to split this in x equals negative 16 divided by his own 2. Plus or minus 6i divided by his own 2. All right, and now we can deal with each fraction individually. So guys, this is a plus or minus, this is your bi. This is your imaginary part, this is your real part. So guys, what is negative 16 divided by 2? It's negative 8. And then plus or minus, I am allowed to divide the 2 numbers in front. 6 divided by 2, guys, that's 3. That's plus or minus 3i. So you end up with 2 completely different imaginary numbers as your answer. One answer is when you take negative 8 and you add 3i to it. And the other answer is when you take negative 8 and you subtract 3i from it. And those are your 2 completely different imaginary answers. But I would just write it like this on Delta Math. Just keep them together as one answer combined, as 2 answers combined. All right? And again, what does it mean? It means that if you were to graph this parabola, it would not cross over the x-axis because the only x values that make his equation equal 0 are imaginary numbers. The only numbers that make his equation equal 0 are imaginary. They're not real, okay? All right, so let me show you how you type it in. So you go over to Delta Math. All right, if you guys look down here, I'm in this little answer box down here. So I would just, on my keyboard, negative 8, plus or minus 3, and then you literally just use the I off of your keyboard, like you were typing the letter I. So negative 8 plus or minus 3i. Then I'll submit my answer, yes, and you'll get your green check, okay? Is everybody okay with that? Guys at home, are you all right? All right, let me try another one. Let me show you another scenario that could happen. Again, I just gotta find the problem off of Delta Math. Just give me a second. Give me 1 second. This could work. Okay. All right, let's try this one. All right, guys, let's try this one as example 3. All right, 16 x squared minus 32x plus 17 equals 0. Let's try that one now. All right, so here we go. If I'm going to solve this degree 2 quadratic equation, I want everything on one side set equal to 0. I definitely don't think I want to factor it, right? It's got this, so I can't use square roots, so let's use that quadratic formula. A is 16, B is negative 32, and C is 17. Let's plug them in. X will equal, the opposite of B is positive 32, plus or minus the square root of, now I need B squared, negative 32, the whole thing squared. Subtract 4, times it with A, which is 16, times it with C, which is 17. And then it's all going to be divided by 2 times 16. All right, let's go to it, guys. Go to that square root. What number does that become? It better be negative because they're all negative today. So X will equal 32 plus or minus the square root of. Type that into your calculator. Don't put it under a square root. Just tell me what number you get. You should get negative 64. And then it's all divided by 2 times 16, 32. All right, so let's take the square root of negative 64. We have to fix him. So take it off to the side, and let's see what we get. We know the answer to that is not real. So I know I'm going to break it up into the square root of negative 1 and the square root of positive 64. The square root of negative 1 is I. The square root of 64 is 8. So I times 8, that's 8i. So now I have to take the square root of negative 64 out, put 8i in its place. Let's go up here now. Okay, now again, you've kind of hit a wall in the sense that I'm not really able to take a real number and add or subtract it with an imaginary number, but I have to simplify it and get it in a plus bi form. So split it. Split it into 2 separate fractions. So x will equal 32 divided by his own 32 plus or minus 8i divided by his own 32. All right, well, guys, 32 divided by 32, that's 1. Plus or minus 8, I am allowed to reduce the numbers in front. 8 does not divide by 32, but it reduces to 1/4. So that's 1i divided by 4. And that's your simplified a plus bi answer. It's 2 imaginary numbers. One answer is when I take 1 and add 1/4 I. And the second answer is when I take 1 and subtract 1/4 I. But I would just leave it as the 2 answers in 1. All right, so let's type that into Delta Math and let's see what it looks like. So I'm over here, guys. I want to type in 1 plus or minus 1i / 4. So guys, that's one way to write your answer. The book, though, the Delta Math, they'll also let you do this. You're allowed to write the I next to the fraction. you're allowed to write it as 1/4 times I. So you can put I on top, or you could put I next to the fraction. You cannot put I on bottom, because that's not where I is. You can either go on top or next to the fraction. So I have a feeling a lot of you are just going to leave them on top, so I'm going to leave them on top too. And then hit submit answer. Yep, that's what I want, and you'll get your green check, okay? Everybody okay with that? All right, let me show you one more scenario, one more problem, and we are done. Let me grab one off Delta Math again. Just let me grab it, so give me 1 second. Let's do this one. Let's do this one. Okay, last one. 4x squared plus 6 equals negative 9x. All right, guys, remember, if you're going to solve a quadratic equation using the quadratic formula, guys, can anybody unmute? Can you still hear me? Because your cameras are, okay, because your cameras just went blank. So I just want to make sure that you guys can still hear me at least. All right. If I go out of control, can someone just let me know? Yes? Thumbs up, we're okay? All right, thank you. All right, here we go. So let's get everything on one side. So let's add these 9x's over so that it's equal to 0, and I'll be able to identify my A, B, and C. Make sure you write it in the right order. 4x squared plus 9x should be next, then plus 6, and then equals 0. All right, so in this problem, A is 4, B is 9, and C is 6. Everybody plug them in. X equals the opposite of B, negative 9, plus or minus the square root of 9 squared, minus 4 times A, which is 4, times C, which is 6. And then it's all going to be divided by 2 times A, which is 4. All right, let's figure out what number is underneath that square root. Negative 9 plus or minus the square root of. Who does that become? I just want to double check. You should get negative 15. All divided by 8. Okay? Well, guys, we got to fix the square root of negative 15, so take them off to the side. We're going to break them up into the square root of negative 1 and the square root of 15, because we know that's no real number. That's definitely imaginary. So the square root of negative 1 is I. That's our imaginary unit. And then, guys, look at the square root of 15. Can you take the square root of 15? No. Can you simplify the square root of 15? Do any perfect squares divide evenly into it? No. So, guys, that's already a simplified square root. It's just going to be I times the square root of 15. Now, sometimes that'll be a number you have to split up into 2 more radicals and reduce it. Lucky for us, 15 doesn't have any perfect squares that divide evenly in. All right, so let's put that in its place. So now we're going to get x equals negative 9 plus or minus I times the square root of 15, all divided by 8. So guys, there's really nothing for us to do, but now we got to split it. We got to create this A plus BI form and see if I can reduce anything. So x equals negative 9 over his own 8 plus or minus I times the square root of 15 divided by his own 8. So now look, does negative 9 divide or reduce with 8? No. And then there's a 1 in front of this I that's assumed to be there. 1 doesn't divide or reduce with 8. So that is a simplified fraction as well. And this is your final answer. I have my A plus BI form. So now let's type that in. All right, we're going to do -9 divided by 8, right arrow, get out of that fraction, plus or minus. Now I want I times the square root of 15. Make sure you right arrow out of that square root and then divide by 8. Now guys, they're going to let you put the I in front of the square root, or they let you put I, like I said, they let you put I next to that fraction like that, if you wanted to write it like that. All right, if you wanted to write the I next to it, you are allowed to. I don't think any of you are really going to do that. I would just leave them as I times the square root of 15 on top. And then you can hit submit answer, and you'll get your green check, okay? All right, are you guys okay with that? Everybody all right? Okay, so guys, here's the deal. You have 3 problems for homework tonight. They are due tomorrow night at 11:45 like normal. Now remember, this was our last Google Meet for the week. I am not here tomorrow, Thursday, and Friday. So every single day, Wednesday, Thursday, Friday, I left you guys an attendance question that you have to answer, just yes, I'm here, and 3 problems. So every single day you have 3 problems to do. That's all I'm making you do. No Google Meets, just do 3 problems each day, and they'll be posted on Google Classroom, all right? And they're in Delta Math. But every day, like tomorrow's problems are due tomorrow night. Thursday's problems are due Thursday night. Friday's problems are due Friday night, all right? So all 3 problems are due on the day that I assigned them. Thumbs up that you guys understand that. All right, so every day, answer the attendance question and do your 3 problems on Delta Math, okay? All right, let me double check guys, and if you have to get a hold of me, Remind will be the best way. Some of you have chosen to not sign up for Remind, and I don't know why, but Remind will be the best way to get a hold of me when I'm away. All right.